Alright, this video is about graphing logarithmic functions. And so if we start with the first one, f of x is equal to the natural log of x, we gotta recall that ln of x means log base e of x, and e is 2.7 something. It's a number bigger than 1. And so what that means is that the natural log of x will look like every log graph without any transformations going on where the base is bigger than 1. So what we see with these graphs is an x-intercept right here at 1, 0, a vertical asymptote right here at x equals to 0. It will hug the y-axis, and then it will, oops, that's not hugging very well, and then it will increase like that. This is what the basic look of a logarithmic function looks like, where the base is bigger than 1. So the domain is from 0 to infinity. Again, you can only put in positive numbers into the argument of a log. The range is all reals, negative infinity to positive infinity, and the vertical asymptote is x equals to 0. Okay, let's go down here. Down here, we see that this function f of x is equal to negative log base 3 of x. Okay. First you say, what is the base? And the base is 3. And 3 is bigger than 1. So any base bigger than 1 will have the same look of a logarithmic graph like this, where the base is bigger than 1. So that's the basic graph. However, this has got a reflection going on because of this negative right there. So a negative in front of that causes a reflection across the x-axis. So that means this part will be down here, and this part will be up here. So what that looks like, it will still have this x-intercept here, only this time it will be hugging the y-axis and decreasing like that. It will turn into a decreasing graph. This is the transformation of a log function that's been reflected across the x-axis because of that negative in front. The domain is still 0 to infinity. The range is still negative infinity to positive infinity. And x equals to 0 is the vertical asymptote. But that negative caused it to flip across the x-axis. All right, let's look at this one. This is the natural log of x minus 2 plus 1. First you say, what is the base? The base is e. E is bigger than 1, so the basic graph will look like this. What's happening with this? Well, we've got this x minus 2, and the negative 2 is in there with the x, and that indicates a horizontal shift, and it's opposite of what it appears to be. So that means we're going to shift this to the right 2, and this 1 that's out there tacked on the outside is what it appears to be, a vertical shift of up 1. We're going to take this graph, and we're going to shift it right 2, up 1. So if we take, this is the origin, and it's going to get shifted 1, 2, up 1. So this is my new sort of xy axis. So if this is my new xy axis, then right here is the new y axis. It got shifted right there. And so the vertical asymptote is no longer x equals to 0. It is x is equal to 2. And the intercept is always 1 to the right of where the origin is. So if this is my new origin, then right here is where that little intercept would be. This is just one of an infinite amount of points on this graph. It just helps me to graph it. So this is how I sort of lay out my log graph after I see that. Then we can say the domain is from 2 to infinity, and the range is all reals. All right, lastly, let's have a look at this guy. This is log base 5 of x minus 1 plus 2. All right. So, what's happening here? Well, first you say, what's the base? The base is 5, and 5 is bigger than 1, so that means the basic graph will be this same look. What's happening with it? Well, it's got this negative 1, and negative 1 means it's being shifted to the right one because this is a horizontal shift opposite of what it appears to be. Plus 2 got tacked on the end. This means it's up 2. Vertical shift up 2. So we're going to go right 1, up 2. So that means the origin gets shifted right 1, up 2. And the entire graph gets shifted. So if this is my new xy intercept, then this is my new vertical asymptote which will be x equals to 1. Right here, to the right of the origin, is where the intercept would be. So that means that you're just going to kind of lay out your log graph like that. And so the domain is from 1 to infinity. The range is all reals. And the vertical asymptote is x is equal to 1.